I'm going to go over how to solve equations with variables on both sides. If we take a look at this first example here, we've got 5x minus 12 is equal to 2x plus 3. The problem with this equation is that our x's are not together on the same side. I can't just add the 12 and divide by 5 because I still have an x that would be stuck over here in my answer. So here's how we're going to solve this. You can move these numbers before you move the x's, but it really is always a good idea, I think, to move the x's together first, because then you'll be more familiar with the problem after that first step. So the first thing I'm going to do, I always like to move the x's first. You don't have to. It's a good idea. I'm going to take this 2x, and we can move it to the other side using addition or subtraction. So in this case, I'm going to subtract, since that 2x is positive, I'm going to subtract the 2x to the 5x over here. So again, if I do it on the left, I also have to do it on the right. So I've subtracted 2x on both sides. We'll cancel this 2x out. And now 5x minus 2x is 3x. So it's 3x minus 12 is equal to 3. And now from here, you can see that this is an equation that you should be familiar with solving. Okay. Again, I just have to move the furthest number from the x. I'll add the 12 over. Gives me 3x equals 15. And then finally, if I divide by 3 on both sides, I should get x equals 5. And to check our answer, just like before, we have to plug the 5 in for the x's. So I'll check this first example. I'll leave it to you guys to check the future ones. But if I take this 5 and I plug it in for x everywhere we go here, just rewriting the same equation, but I'm leaving blanks in for the x's. And again, I'm going to take my answer and plug it in here. So 5 times 5 gives me 25 minus 12 is equal to 2 times 5 is 10. So that'd be 10 plus 3. And we'll check this out. 25 minus 12 is 13. 10 plus 3 is also 13. So we know we have the right answer there. That is true. So x equals 5 is the solution to this equation. Okay? We're going to look down here at another example, very similar. There's just one extra step here at the beginning. And there's multiple ways to solve these problems. I'm going to try to show you the ones that will keep you out of the most trouble. Okay? The best idea when you have an equation like this is to start by looking to see if there's any like terms on the left side or the right side first. If you notice up here, on the left side, we didn't have any like terms, and on the right side, we didn't have any like terms, so I didn't combine anything. If you look here, I do have like terms on the left side. The 3x and the positive, again, that's like a 1x, will combine. So 3x plus 1x should give me 4x. I could subtract the x over and subtract the 3x over. The common mistake, though, that people make when they try to move too much, it takes a little too much work. This is a mistake. People will try to subtract 1x from this side and this side. You cannot subtract something from the same side twice. If you do it once here, you have to do it over here too. So be careful for that mistake. What I'm going to do, though, again, is just combine the like terms. Should make my steps a little bit easier. So 3x and 1x should give me 4x. So it's 4x minus 9 is equal to 12x plus 6. And now what I'll do is, again, I could either move the 4x over to this side or the 12x over to this side using addition and subtraction. And I guess I'll stick with the theme here. I'll move the 12x over to the left, which will give me a negative number, but that's no problemo. It'll still give us the same answer either way. So I'll get negative 8x minus 9 is equal to 6. Now I've just got to move the 9 over by adding it. So that gives me negative 8x is equal to 15. And then finally here, if I divide by negative 8 on both sides, that doesn't look like it's going to reduce. So my answer here should be x equals negative 15 over 8 for my answer. So negative 15 over 8. I apologize for my handwriting sometimes. It's not the best, but you get the idea. Okay, we got one more example up here dealing with this type of problem, except now we've got parentheses and we have to look at how are we going to get rid of these parentheses so we can solve it just like we did on this problem before it. So if I start here, always the first step in these types of problems is you want to get rid of parentheses using the distributive property. So I'm going to start by distributing this 3 into the parentheses. So if I distribute this 3 in, I should get 3x. So 3 times x is 3x. 3 times that 4 should give me 12, so it would be minus 12. And now I'm just going to bring everything else down. The plus x, no parentheses over here, so I'm just going to bring all this down. Now once again, just like we did in this last problem over here, I'm going to look for like terms that are already on the same side. Again, I'm not thinking about moving things across the equal sign yet. I'm just looking at like terms. So here I've got a 3x and an x. That's actually kind of similar to the last one we had. We already know that that's going to give us a 4x. So I'm going to write 4x. Won't combine with the 12, so I'll bring down the minus 12. Over here, I also have like terms, you can see. I've got a negative 8 and a 7. That'll give me a minus 1. So I'll bring down the 2x, nothing to combine here. We'll get 2x minus 1. And now, once again, I'm ready to start moving things around now that everything on each side doesn't have any like terms. So I'm going to start by bringing this 2x over to the left side. So I'll subtract 2x from both sides. That'll give me 2x minus 12 is equal to negative 1. And then I'm going to take this 12 and I'm going to add it over to this side. So I'm sort of running out of room here, but I'll sneak a plus 12 in here. So that gives me 2x. Negative 1 plus 12 should give me 11. And then if I divide by 2 on both sides, again, I can leave that as 11 over 2. If you prefer, you could write it as 5 1/2 or 5.5. Those are all the same answers. All right, we've got one more to go here. And this one is maybe going to be a little tricky here because everybody seems to not like fractions too much. I'm going to free up a little bit of space here so I can not cram my example together. Okay. So now what I'm going to do here, if you look, we've got all these fractions and it looks really complicated, and it can be if you're not, if you get intimidated by it. There are a few ways to do this. One way is you could just treat this the same way we did before. You could subtract this fraction. You could subtract your x's over to the other side, or you could subtract this 1/2 over to this side, whichever you want to do. The way I'm going to suggest that you do this, though, is I'm going to suggest that you do something called multiplying by the least common denominator. And the least common denominator is just going to be the number that if you multiplied through by this number would cancel out all your fractions. In this case, if you look at all the denominators, we got 3, 6, 4, and 2. In this case, the least common multiple, or the least common denominator for all of these is 12, meaning that each of these numbers evenly divides into 12. 3 goes into 12 4 times, 6 goes into 12 2 times, 4 goes into 12 3 times, 2 goes into 12 6 times. So what I'm going to do now is I'm just going to take this whole equation, and we know that for equations we're allowed to multiply something on both sides. I'm just going to multiply by 12 on both sides, basically multiply every term in here through by 12. So I'll start with the first one. Again, if you're allowed to use your calculator, you can punch this right in your calculator, 12 times 2 over 3. I'm just going to do this in my head here, and here's how I would do that. I would take 12 divided by 3 times 2. So 12 divided by 3 is 4, times 2 is 8, so that gives me 8x. Bring it to the next one. 12 divided by 6 is 2, times 7 is 14, so that'll give me a minus 14. Notice that the fractions are clearing out after I'm multiplying everything through by 12. There aren't any fractions left here. 12 times 5 over 4, so 12 divided by 4 is 3, times 5 is 15. Keep going here. 12 times 1/2 is 6. So half of 12 is 6. That'd be 6x. And we're getting pretty darn close here. Next thing I'm going to do, just like before, I'm going to move all my x's to the same side. And again, it doesn't matter what side you move this to, so maybe just for the sake of argument, it'd be easier to do it the other way, but just to show you that I can move it on this side too, I'm going to subtract 8x over this direction. I would think personally if it was me, I would move the 6x over, but just to show you here. So this would cancel. You get negative 14 equals 15 minus 2x. And now from here, I've just got to move the 15, move the numbers to the other side. And I've got negative 29 is equal to negative 2x. So our final step here will just be to divide by 2. And that would give me x is equal to, that should be a negative 2, I'm sorry, negative 2. That should give me a positive 29 over 2 for my answer. So again, the key here, I like to break this down into a few steps. The first step would be, if you see any parentheses, distribute them using the distributive property. Okay, so get rid of the parentheses first. If you see any like terms, like we saw in this problem over here, if you see any like terms on the same side, combine them. Okay. After that, move all your x's to one side using addition and subtraction, and then move all your numbers without the x's to the other side using addition and subtraction. And that's just a basic strategy to solve any linear equation that should get you in the right direction.